Now take this numerical from the chapter System of Particles. A rope of negligible mass is wound round a hollow cylinder of mass 3 kg and radius 40 centimeters. What is the angular acceleration of the cylinder if the rope is pulled with a force of 30 newtons? And what is the linear acceleration of the rope? Assume that there is no slipping. So over here, M is equal to 3 kg. So mass is 3 kg and radius is 40 centimeters. We are converting the centimeters into meters. So 40 centimeters is 0.4 meters. Now we will find moment of inertia. So because a hollow cylinder is given, so moment of inertia of the hollow cylinder is hollow cylinder about its axis. Its formula is I is equal to mr square. So m is 3 and r is 0.4 whole square. So if you solve this, you will get 0.48 kg meter square. Now we need to find out the force applied. Force applied is already given in the question. Force applied F is 30 newtons. Therefore, let us find out torque. So torque is denoted by tau and its formula is F into R. So that is 30 into 0.4, which is equal to 12 Newton meter. Now if alpha is angular acceleration produced, then from tau is equal to I alpha, we can find out alpha. Alpha is tau by I. So tau is 12 by I is 0.48. If you divide this, you will get 25 radian per second square. So after finding alpha, we will find linear acceleration. So linear acceleration is denoted by small a and its formula is R alpha. So that is R is 0.4 into alpha is 25. So that is 10 meters per second square. Now take the second numerical. A coin is placed at a distance of 10 centimeter from the center of a circular turntable. If the coefficient of static friction between the table and the coin is 0.8, then find the frequency or rotation of the disc at which the coin will just begin to slip. So first let us write down what is given to us. So distance of coin is given to us. Distance of coin we will denote it by R, that is 10 centimeter. Let us convert this centimeter into meter, so that is 0.1 meters. Now what else is given to us? Coefficient of friction is given. Coefficient of friction is denoted by mu, that is 0.8. And what is frequency of rotation? Frequency of rotation means number of rotations per second. So we have a condition for coin not to slip. So we have a condition that is mu mg equals mr omega square. From here, if you want to find out omega, so omega square equals to, here m and m get cancelled. Omega square equals to mu g by r. So we get omega equals to root over mu g by r. Now we need to substitute the values here. So omega is equal to root over mu is 0.8 and g is 9.8 by r is 0.1. This decimal and this decimal will be cancelled. So if you multiply 8 into 9 times 9.8, we will get 78.4. And if you take the square root of 78.4, you will get approximately 8.854 radians per second. Now after finding omega value, number of rotations per second, that is equal to rotational frequency. We have a formula for this, that is omega by 2 pi. So omega value is 8.854 by 2 pi. So if you solve this, that is 1.409 rotations per second, or you can say rotations per minute. 1 minute. This is rotations per second, RPS. And if you convert the seconds into minutes, you will get 84.54 rotation per minute. Now take this question. Find the torque of a force 7I bar plus 3J bar minus 5K bar about the origin. The force acts on a particle whose position vector is I bar minus J bar plus K bar. This numerical is very important. So first let us write down force vector is given to us. Force F bar equals 7I bar plus 3J bar minus 5K bar. And what is the position vector? Position of particle is given by R bar is equal to I bar minus J bar plus K bar. Now torque is given by tau is equal to R bar cross F bar. So that is, we need to find the vector product of both. First you write R bar vector 1. First we write ijk, and then we write the coefficients of ijk from R bar 1, minus 1 and 1, and then we take from F bar 7, 3 and minus 5. So that is I bar into, now we cross multiply this, 5 minus 3 minus J bar into, cross multiply the corners, so you will get minus 5 minus 7 plus K bar into, cross multiply this, 3 plus 7. So that is 2I bar plus 12J bar plus 10K bar. So this is the torque vector. Now we need to find out magnitude of torque. So magnitude of torque is root a square plus b square plus c square. So that is root 2 square is 4, 12 square is 144, 10 square is 100. So that is root over 248 units. Now take this question. Calculate the moment of inertia of a flywheel if its angular velocity is increased from 60 rpm to 180 rpm when 100 joule of work is done on it. So first let us write down what is given to us. Work done is 100 joules. And omega 1, angular velocity is denoted by omega 1, that is 60 rpm. And we are converting rpm to rps, that is minute to second we are converting. So that is 1 rps, and that is 2 pi radians. The same way omega 2 is 180 rpm, that is 3 rps, which is equal to 6 pi radian. Now we need to find out work done. Work done is already given here, 100 joules. We have a formula for work done, that is half mod omega 2 square minus, this is half I omega square, half I omega 2 square minus half I omega 1 square. Now in the place of work done we write 100 joules, that is half. If I take I common, I is 1. I we don't know how much it is. So omega 2 square is 36 pi square minus 4 pi square. So from this we are taking half common. We don't know what is moment of inertia. We are writing it as I. And omega 2 is 6 pi. So omega 2 square will be 36 pi square. And omega 1 is 2 pi. So omega 1 square will be 4 pi square. Now if I cross multiply, this 2 goes there and becomes 200. I into 36 minus 4 is 32 pi square. So if you want to find out I is 200 by 32 pi square. And if you calculate it, you will get 0.6332 kg meter square. Or you can approximate this value as 0.63 kg meter square. This is moment of inertia. Take the next numerical. This is also based on moment of inertia, very, very important. So the moment of inertia of a flywheel making 300 revolutions per minute is 0.3 kg meter square. Find the torque required to bring it to rest in 20 seconds. So what is moment of inertia? Denoted by I, that is 0.3 kg meter square. And time t equals 20 seconds. Omega 1 is 300 RPM. RPM is revolutions per minute. Now we are converting this into revolutions per second by dividing it by 60. So 300 by 60 is 5 RPS. And omega 2 is equal to 0 because it is coming to rest. So the final velocity is 0. Now we have a formula for torque. Torque is denoted by tau, that is I alpha. I is 0.3 and alpha is 5 into 2 pi by 20. If you cancel these all, you get 0.471 Newton meter.